Hi, welcome to Exam Debug. I'm Chris, and today I'm going to be taking you through what an expert system is. So we're going to be looking at what's an expert system, some examples, some of the different parts, and then some of the advantages and disadvantages of using an expert system. So stay with us if you want to find that out. Hi, welcome back. So today we're going to be looking at expert systems, and this is for the course IGCSE ICT, and it's in the unit how ICT is used. But again, you can use it with other programs as well, with other exams. So what is an expert system? In short, it's a system which is expert at something. So perhaps a more detailed description would be there are many jobs that we have nowadays that we would perhaps like to try and replace or to assist with expert knowledge. So it's using a computer to help analyze or diagnose or come to some conclusion about something based on a set criteria. Some examples are maybe like plant or animals. So maybe someone is going out, they're an amateur, and they want to identify different animals in an area. So instead of having to memorize, as they would in the past, all the different types of animals and all the different colors, they can simply answer a series of questions into their telephone app. Does it live on water or land? Things like this. And the computer will be able to identify the particular plant or animal that they are looking at. And it means that person doesn't have to invest all their time on a lot of memorization. That can be done much easier by a computer system. Other examples might be car diagnosis. So someone puts in, some of the problems that they're having, and depending on their answers, they're going to get back a diagnosis of the problem in the car. So they say, does the engine start? Yes, no. Other things like this, and then eventually the result will say something like, you have to replace the spark plugs, or something like that. Sorry, I don't know much about cars, but something like that. Likewise, in game systems, so there's going to have to be a certain amount of decisions made depending on what the other player does. So an example is chess game is going to use an expert system to try and work out what the next move is that should be made by the computer. So let's have a look at an expert system. Alright, so here we are at the NHS website. The NHS is the health service of the UK. And they've made this website because a lot of people were perhaps making the wrong choices when it came to medical problems. So people were either coming to the hospital when it wasn't necessary, or they were staying at home when they should have been going to the hospital in an emergency case, for example. So they made this website. So this website is specifically for non-professionals. So this is not designed for a doctor to help a doctor. However, a doctor may have a similar style system with obviously more detail, maybe more options in his surgery or in his hospital to help him with his job as well. So that this one is not replacing a doctor, but is just helping people make the right choices. But you can also have systems for professionals as well. So it can be both. Anyway, so let's have a quick look at this one. So I've already gone a little bit into this and given it some information. And I've said that I have some joint pain and some swelling, possibly. So it's going to ask me some questions, and then it's going to tell me what I should do in response to my answers. So was the joint pain or swelling caused by an injury? Yes, it was. Have you seen a healthcare professional about the problem? No, sorry, I haven't yet. It's going to be a little bit slow today. Was the injury caused by a large force? Yes. Something fell on me, maybe. Okay. Is your skin warm or cold? My skin is cold. Is your skin wet or dry? It feels wet. Okay, and then it's saying that whatever I put in there has shown that I have to call an ambulance immediately. So again, it's not told me what my problem is, but it does suggest on the previous page that it's something to do with shock. So if I've got shock, I have to go to the hospital right away. So there's an example of it's a reasonably simple expert system. As long as you appreciate that expert systems can get much more complicated. This is the simplest end of an expert system. So hopefully that gives you some idea of what an expert system is. But now let's have a look at the parts that make up an expert system. So one thing I just want to say first though is that a lot of websites won't have this one here, the rules base, in it. And for many courses this won't be considered as part of the expert system, or it will be enfolded, it will be encompassed in one of these other areas. So, but for IGCSE, we have 4 parts. If you have a look on some other places, you'll see they only put up 3. So be careful with that, because they'll sometimes ask for 4 in the IGCSE exam. So let's have a look at these parts. So the first one is the easy one, the user interface. So hopefully you understand what that is already from GUIs and CLIs and WIMP. So this is the part where we speak to the user and we get information from them. How do we do that? In this case that we just seen in the NHS website, we were using a web browser and a website to get that information from the user and to pass back information to the user as well. The next one is the knowledge base. So if you're like, this is the raw data. This is the sort of key facts that are going on there. It is the database, really. So when we have the knowledge base, it is the database. The rules base, and again, this one is sometimes not counted in other places. The rules base is how this knowledge in the database, how this data connects together. For example, usually this will be if statements or if-then statements. So for example, if the engine won't start, and if there is fuel in the car, then the problem is going to be the spark plugs. So again, this is how this stuff fits together. How does it connect together? We'll have a look at that in a bit more detail in a second. Our final part here is the kind of the brain of the whole thing, the inference engine. So in a simple system, this is just going to maybe return a simple solution. But once we get into more complex areas, the inference engine is going to take this information from here, from the knowledge base and the rules base, combine it with the user's entries, and it's going to come to some conclusion. It's going to create some new knowledge based on what has come from here already. And this gets more and more complex as you get into more and more complex systems. But in a simple one, it might just be returning the data. So let's have a look at that on a very simple database. Okay, so let's have a look at this little database then. First thing I want to say is I'm not saying for a moment that this is a good example of how you should store things in a database, nor am I saying it's a good example of an expert system at all. I'm just trying to illustrate it in a different way so that people can maybe get a better idea of the different parts. So let's start with the knowledge base. So I have this table here, knowledge base, and what we have to do is we have to talk to an expert, and we have to get information for the knowledge base and the rules base. So in this case, my knowledge base is a simple database with different problems, and then I've just used yes, no, Boolean types for the corresponding symptoms. So the knowledge base is just that bare knowledge that we've taken from the experts. We need to start putting that together though. So we've already kind of done it here, but to put it together, we have to connect these things. So we have to say that, we have to do a series of if questions. So in this case, the user has given us some answers. So if it's swollen, yes. If it's cold, yes. And if it's an injury, yes. And the others are no or not counted by default. Then I have shock. So the knowledge base is the simple facts. The rules base is how these connect together. What's the criteria there? And both of these have to come from an expert. The inference engine is going to be more of a program solution rather than a database solution. But, for example, a very simple inference engine might take those questions, apply the query to the database to get the result. Once it has the result, it's then going to search for the result in the solution table. So it's shock. So the solution is that I have to go to hospital. So the knowledge base contains the basic facts. The rules base shows how these all connect together with ifs and thens. The inference engine is going to take those and in as much a way as a computer can, think about it in a certain sense and make choices, make decisions. For example, it might look up a table or it might do something a lot more complex than that. So that's a very basic example. Okay, so let's have a look at some of the advantages of expert systems. So first of all, expert systems are consistent. That means that whatever answers we give to those questions, we're always going to get the same results back from the expert system. And this can be very useful in certain lines of work. For example, let's say, we have car mechanics. They all have different preferences, perhaps. And you might get different solutions from different car mechanics. Whereas the idea of an expert system is that you've had some of the top experts already agree on what would be the best solution to that problem. Likewise, a friend of mine, he used to work in a call center for a bank. And what would happen was the call would come in and the question would appear on the screen for my friend working there, and he had to read it. He would put the answer in, and the expert system would tell him the next question that he had to say to the customer. In this way, the bank was able to give a consistent experience to the customers all the way throughout, even when my friend was not. He didn't have a degree in banking or anything, so he was quite a low-skilled worker, but he could provide the same consistent expert experience. Next one, kind of similar, but no human error. So let's say, for example, we have a doctor, and he's had a really bad day. His wife has been shouting at him, his kids were screaming all the way to school, and you're his first patient of the morning after he's had very little sleep. And you come to him with a problem that is maybe not very common, and he studied it 20 years ago when he was at university. So there's a very good chance that he won't recognize the problem that you are having. An expert system helps to eliminate that kind of issue. So it doesn't get tired, it doesn't make silly mistakes like a human would. Saves time. So there are lots of situations, for example, with the NHS 24 website. This saves doctors a lot of time because people can go onto the website and find what they should be doing before they go to the hospital. So it means a lot of people with simple problems can find out first that they should treat themselves at home, and that saves the doctors in A&E, in casualty, a lot of time. And as I was saying, you can have a less skilled workforce. So if you have an expert system, like in the bank call center, where it's effectively answering the questions for the person that's working there, they don't have to have those banking skills. They don't have to have that knowledge about the bank. All they have to concentrate on is good customer service and being polite, and they can let the computer do the thinking side for them. And so you can hire less skilled people to do that same job in some situations. For example, I don't think in the immediate time doctors are going to be replaced by expert systems, although they might be used to help them. Likewise, it means we can bring expert knowledge to places where maybe they didn't have it before. Rural communities, isolated areas. They can use computers to help them answer these complex questions that you would need to fly in an expert for before previously. But there are also disadvantages. So there can be errors in the knowledge base, and while it's true the expert system will give consistent answers, if the knowledge base is wrong, it will give consistent mistakes. So we have to make sure our knowledge base is correct. So it doesn't entirely remove the human error, because when we're creating the expert system, we rely on human experts to bring that knowledge, to give us the rules base. So if there's a mistake there, we're in a lot of trouble. Likewise, things don't always stay the same. There's new medical discoveries, treatments change, cars change over time, things like this, the way the bank does business, the services they offer, these are going to change regularly. And so we have to make sure our expert system stays up to date with the current changes. Likewise, expense. So collecting all that information from these top experts and building the system, paying programmers, paying for the database, this has a lot of expensive startup costs. So we have to be aware that it's not cheap to have an expert system. Over time, however, we can employ a less skilled workforce. So this is probably going to save us some money. If we don't have to hire expert bankers in your call center, if we can just hire high school graduates, for example, we can pay them a lot less money. So over the long term, we can potentially save money. But it is expensive to start up our system. Lack of common sense is another important one. I mean, the expert system can only factor in things that we have told it to factor in. For example, expert systems are sometimes used in oil and gas exploration. So maybe it decides because of different geological factors that we should be searching in the North Sea at a particular place. However, what it hasn't been told is that there is a rare bird sanctuary in that place, or that there is a community of 15 people who have lived there for generations on a nearby island. And it can't factor in certain human elements unless it has been programmed to deal with them. So there can be things that seem obvious to us that the expert system just can't deal with. And likewise, emotional things, people coming to the doctor and complaining about things that, maybe they're exaggerating their problems. So the expert system can't pick up on that. It takes your answers as factual, whereas a doctor maybe will be more skeptical when you say certain things, and will be able to help deal with it on that side of things. Training is also needed. So, like we said, we do have a less skilled workforce perhaps, but we're still going to have to train them on how to use that expert system. And so that changeover of time can, again, cost us more money at the beginning. And, to keep up the training, it can cause some problems as well, or it can be a disadvantage. Okay, so great. That's all for expert systems today. Please come along, check out the website, examdebug.com. Make your own videos, send them in. We'd like to see them. And please subscribe as well. So thanks very much, and good luck with your exams.